Alright, welcome to the next lesson. In this lesson, we're going to be solving for unknown variable in our straight lines, okay? So let me just explain with the example. So have a read of question 1. Question 1 says the straight line with the equation y is equal to mx minus 5 passes through this coordinate and we need to find the value of m, okay? So let me just explain graphically what's going on here, okay? Let me draw axes. And can you guys tell me what is the y-intercept of this graph? The y-intercept of this graph, you can see from here, is the c value is negative 5. So we can plot the y-intercept here, 0, negative 5. And what's m? Well, m is a variable. M is a thing that can change, right? So what's happening with this line is it has to go to the y-intercept, which is 0, negative 5. But the gradient can be anything. So we could have a positive gradient, negative gradient, a flat gradient, right? So you can see a gradient, it can be anything depending on the value of m. Okay, so gradient is the variable. So what's changing over here, guys? The only condition the question is saying is it has to go to negative 210. So where's negative 210? Let's plot it out. Okay, let's plot negative 2 and 10 out. So negative 2 is here, and negative 10 would be roughly here, let's say. And then the question is saying this graph has to go through that coordinate negative 2 and 10. Negative 2 and 10. Okay, so now we have to find the value of m so that this graph has a gradient for which it will go through negative 2 and 10. Okay, so I'm making it seem really complicated, but it's not. I just want to visualize, I just want you guys to visualize what's going on. So negative 2, 10, what we all have to do to find the value of m is simply just sub negative 2 and 10 into the formula, okay, to find the value of m. So negative 2 is pretty much an x value and 10 is a y value. So replace y with 10 is equal to m multiplied by x value is negative 2 minus 5. So pretty much you have 10 is equal to negative 2m minus 5. Take 5 to the other side by adding. So you go 15 is equal to negative 2m. M is equal to negative 15 over 2 if you just divide both sides by negative 2. Okay, that's it. Simple as that. So what we did is we made the gradient negative 15 on 2 so that it goes through this coordinate, right? So that's the conceptual part of what's happening. But really simply, in simple terms, all you have to do is sub this coordinate into the equation. Okay, let's move on to the next question. So a straight line has the equation y is equal to mx plus 4. So you'll notice this time, right, it's saying a y-intercept is 4, so the y-intercept is 0 and 4. Okay, now also the gradient is changing. So gradient is the variable that's changing. Just quick note, it's saying that there is a negative gradient, right? If m is less than 0, remember m is negative, that means we have a negative slope, so kind of going downwards like that. All right, so let's do it. Find the x-intercept of the line in terms of m. So our equation is y is equal to mx plus 4, and our question part A is asking find the x-intercept. Okay, and this is the same as we've been doing so far. So x-intercept, you make the y value is equal to 0. So 0 is equal to mx plus 4. And just solve for this. Take 4 to the other side. Negative 4 is equal to mx. X is equal to, if you divide by m, is negative 4 over m. So I just divide both sides by m. Okay, so this is our x-intercept in terms of m. So if you had to write this in a coordinate, it would be, for example, negative 4 on m, comma 0. Alright, so again, I want you guys to not just understand this with the equations. I want you to understand what's going on graphically. Okay, so I'll show you this with the graph. So the y-intercept is at 0 and 4, which is up here, 0, 4. Right? So what's the thing that's changing? The thing that's changing is the gradient, right? So it could have this positive gradient, it could have negative gradient, like so. But it doesn't matter what m is. For example, if this is m or this is m1, right? This intercept will always be negative 4 over m and 0. And this intercept will be negative 4 over m and 0 because we calculated it, right? So it doesn't matter what the gradient is, the x-intercept will always be negative 4 and 0. Negative 4 over m and 0, right? So again, it could be another gradient, like so. And this would also be the same thing, the same gradient, negative 4 and m and 0. All right, so let's keep going. Find the values of m where the x-intercept of the line is less than or equal to 2. All right, so now it's saying in part B, the x-intercept has to be what? Has to be less than or equal to 2. All right, so what is our x-intercept? Well, our x-intercept, we already found in the previous question, is negative 4 on m. So negative 4 on m is our x-intercept, has to be less than or equal to 2. All right, so we're pretty much making this x-intercept has to be lower than 2. So 2 is actually over here, so it has to be anything less than 2. All right, so we're finding the value of the gradient so that our x-intercept is less than 2. That's what's going on in the graph. But equation-wise, it's really simple. You just need to solve this. So negative 4 is less than or equal to 2 times m. So I'm taking m to the other side by multiplying. And then divide by 2. So you have negative 2 is less than or equal to m. So in other words, you can write this as m should be bigger than or equal to negative 2. So if m is bigger than or equal to negative 2, then you'll have your x-intercept to be less than or equal to 2. That's what we did there. All right, I hope you understand. Let's keep going. Don't worry, there's more questions coming. All right, so if you don't understand, we'll do more of them. All right, it's saying the equation of the line that is perpendicular. So there's a line that's perpendicular to y, so part C, y is perpendicular to y equals mx plus 4. We need to find the perpendicular line that passes through the coordinate 0 and negative 2 over 3. Right? So we need to find the line that is perpendicular to this line and has to go through this coordinate. Those are the two conditions pretty much part C is asking for. So first things first, obviously we're finding the equation. Any straight line has equation, y is equal to mx plus c. We have to find the gradient and the y-intercept. Alright, so this is exactly what we did in the previous lesson, perpendicular and parallel lines. Alright, so we know that what's the gradient of the graph of this one here? Well, the gradient is really simple. It's m, right? So our gradient of m1, so m1, remember from the previous chapter, is just m. Right, it's just the variable. So then what is the perpendicular gradient? Remember the formula was the perpendicular gradient is equal to negative 1 over whatever original gradient was. So it's simple. It's literally that, our gradient. So a perpendicular gradient is negative 1 over what our gradient is m. So yes, you can have your perpendicular gradient, have m in there. It's fine. Alright. So what is our what is our perpendicular equation so far? So we can sub this value into y is equal to mx plus c. So y is equal to negative 1 over m is our gradient, x plus c. Alright. So we found the gradient of our graph. The perpendicular gradient is negative 1 on m, and we subbed it back into our general straight line formula. Alright, so the last step, as we always do, is to find c. And how we're going to find c is just sub the coordinate that we have at the start. So we're going to sub 0 and negative 2 on 3 into the equation. So x is equal to 0. So this is replaced with 0. So negative 1 on m. And y is equal to negative 2 on 3. So negative 2 over 3 plus c. So pretty much 0 cancels this out. So you're pretty much left with negative 2 on 3 is equal to c. So c is negative 2 on 3. So what's our equation of the perpendicular gradient? Perpendicular line is going to be negative 1 on m multiplied by x minus c, which is 2 on 3. Okay, so that's pretty much the working out for that part C. All right, more questions. Okay, this one's a little bit different, but I want you guys to pause the video again and have a go at this question yourself. All right, I hope you had a go. Again, try these questions. Don't just watch me do them. It really helps a lot if you actually have a go at these questions. So let's talk through this. So this time, what's the variable? The variable that's changing is c, which is the y-intercept, right? It's y-intercept's changing. But the gradient is the same. What's the gradient of this graph? This gradient of this graph is negative 3. All right, so let's think about this graphically. So let's say our y-intercept is c. So this would be 0 and c. 0 and c. Our gradient this time is negative 3. So it's a steep negative gradient. It looks kind of like this. Okay, so what's the thing that's changing? The thing that's changing is the y-intercept. So pretty much the graph is being moved up and it's being moved down. Up and down. That's what the value of c is doing, right? The value of c is moving the graph up and down, because if c is like 10, so if c is 10, the y-intercept would be, for example, 0 and 10. If the c is maybe 1, be all the way down here, so it's moving the graph down, the y-intercept would be 0 and 1. So that's what's happening graphically. All right, so that's kind of graphical representation, but let's do the question. Find the x-intercept of the line in terms of c. Again, we do the same thing here. The rule for x-intercept is basically simple. Y is equal to 0. Same thing as always. So you do 0 is equal to negative 3x plus c. Right? So now just solve for x. So you take c to the other side by subtracting. Negative c is equal to negative 3x. And then solve for x by dividing both sides by negative 3. Negative 3. So you're left with c on 3, because negative and negative you can cancel, is equal to x. So x-intercept, if you get to put in coordinates, is c over 3 and 0. That's x-intercept, right? So again, graphically, I'll show you really quickly. You don't really need graphs to this question, but I really want you guys to understand conceptually what's going on. That's why I keep saying it over and over again. So pretty much if c was up here, if this was 0 and c, our x-intercept will be c on 3 and 0 down here. Okay, same thing. If you move the graph maybe down quite a bit, okay, our x-intercept would be over here, which would still be c on 3 and 0. Okay, so that's what's happening behind the scenes. All right, part B. Find the value of c for which the x-intercept is greater than 9. So it's similar to what we did before. So it's saying x-intercept has to be just greater than, not including. So just get greater than 9. So then what is x-intercept? X-intercept is c over 3 has to be greater than 9. So then just pretty much really simple, guys. Multiply the 3 across. C is greater than 9 times 3 is 27. All right, so C has to be bigger than 27 if we want an x-intercept to be greater than 9. It's as simple as that. All right. Part C. Part C is asking, find the value of C if the straight line passes through negative 2 and 10. Okay, so we have this equation, y is equal to negative 3x plus c, right, this is part C. And this equation has to pass through which coordinate? Negative 2 and 10. Negative 2 and 10. So pretty much if I had to show this again graphically, again, all of this has to do with the graphs, guys. So this equation, which has a gradient of negative 3, has to pass through negative 2 and 10. So negative 2 is here, 10 is going to be all the way up there. So negative 2 and 10 would be here. So again, if it has a negative gradient of negative 3, so right, we have to find this y-intercept. Pretty much C is the unknown variable. We have to find 0 and C such that it passes to the coordinate negative 2 and 10. That's what's happening graphically. But equation-wise, it's much more simple. All we have to do is sub this coordinate in x and y. Right, so sub this into x and sub 10 into y. Same as always. So y is equal to 10 is equal to negative 3 multiplied by negative 2 plus c. 10 is equal to 6 plus c. And then subtract 6, c is pretty much 4. Okay, that's the answer. C is 4. So find the value of c. We've done it. Okay, last question. Part D is saying that find the equation of the line that is perpendicular to this line. So again, negative 3x plus 3, same as before. And it goes to negative 210, so same coordinate. All right, let's do it. So this time, part D is saying, okay, same equation, 3x plus c. This time, it's perpendicular. We have to find the perpendicular line. And it goes through negative 2 and 10. All right, so again, we do the same thing. We need to find the general straight line formula. Y is equal to mx plus c. And step 1 is to find m. Let's do it. What's the equation for m? The equation of the perpendicular gradient is going to be negative 1 over whatever our original gradient is. So what is our original gradient? Our original gradient in this case is negative 3, right? Mx plus c. So our perpendicular gradient is going to be negative 1 over negative 3, right? Because it's negative 1 over negative 3. And that pretty much becomes 1 over 3. So our perpendicular gradient is 1 on 3, which we can sub into here. All right. So y is equal to, if I sub m in, 1 over 3x plus c. And then c is really simple, guys. We just need to sub this coordinate in and find the answer. So we sub negative 2 and 10 in because it goes to that coordinate. So 10 is equal to 1 on 3. 1 on 3 multiplied by negative 2 plus c. Right? So 10 is equal to negative 2 on 3 plus c. And then you take 2 on 3 to the other side by adding. So 10 plus 2 over 3 is equal to c. And 10 plus 2 on 3 is nothing but 30 on 3 plus 2 over 3 is c. So c is pretty much 30 is 32 over 3. Okay, that's the final answer. So sorry, it's a bit messy, but you know, it's the same sort of flow. You just solve for c and by subbing this in. So your final answer, the perpendicular line, is going to be y is equal to 1 over 3x plus 32 over 3. Okay, that's the answer. Alright, part F is a little bit more tricky. So why don't you guys pause the video and have a go. Alright, let's have a look at this question. It's a little bit more tricky. It's a bit different to what we did thus far. So it's saying A is the x-axis intercept. A is the x-axis intercept. And B is the y-axis intercept of the same graph we've been working at so far in this question. So let's find A and B first, okay, before we do anything. So A is the x-axis intercept, x-intercept. I believe we already found this in question 1, but let's do it again anyway. So remember the rule is y is equal to 0. So 0 is equal to negative 3x plus c. Pretty much if we do the same thing what we did in part A, right, to find the x-axis intercept, you'll have x is equal to c over 3. So the x-axis intercept, or the coordinates of A, the coordinates of A are going to be c over 3 and 0. That's A. So what is B? So we have to find B next. B is the y-axis intercept. So y-intercept is pretty much the rule is x is equal to 0. By the way, you already know what the y-intercept is. It's just c, but I'm just showing you with the equations how you can do with the rule x equals 0. So y is equal to negative 3 multiplied by 0 plus c. So y is just c. So the y-intercept, or the coordinates of B, are 0 and c. 0 and c. So we find B, A and B. So part 1 is asking us to find the midpoint of A and B. So the midpoint. Remember the midpoint formula? It was x1 plus x2 over 2, y1 plus y2 over 2. Okay? So we did this all the way back at the first lesson of this chapter. So remember, this is x1, y1, this is x2, y2. Sub those into the formula and you get the midpoint. So the midpoint of A and B is equal to, so C on 3 plus 0, C on 3 plus 0 divided by 2, so x1 plus x2 divided by 2, and 0 plus C divided by 2, 0 plus C over 2, so y1 plus y2 over 2. Let's try to simplify this. So in other words, you pretty much have C on 3 divided by 2 and C divided by 2. Okay, we can't simplify this, but we can simplify C on 3 divided by 2. Right, that's the same thing. I wrote it in a different form using the division symbol. That's the same as if this is 2 on 1, C on 3 multiplied by half, so flipping the division sign. So this, if you multiply, is going to be C over 6. Right, so what I'm trying to show you there is this simplifies this, C over 6. Right, so the midpoint of A and B is going to be C on 6 and C on 2. C on 6 and C on 2. Alright, so that's pretty much part 1, which is finding the midpoint. Alright, I hope you got that. So part 2, so keep in mind C on 6 and C on 2. Part 2 is saying that the midpoint, which we got over here, which was the midpoint of AB, midpoint was C on 6 and C on 2. They're saying part 2 is saying that this midpoint is 1 over 3, right? Find the value of C where the midpoint of this gradient, this midpoint should be equal to 1 and 3, right? It's very similar to the questions we did in the first lesson of this chapter. I gave you the practice questions, right? So pretty much it's really simple. You make this, the x coordinates the same. C on 6 is equal to 1, and or you can make the y coordinates the same. So C on 2 is equal to 3. So C is equal to 6, so you get the same result here. C is equal to 6. Okay, so pretty much there's only one answer. You only have to write it once. C is equal to 6 is the answer. Alright, I hope you got that. Is the midpoint formula. Alright, part 3. So part 3 I've written again here. O is the origin. If the area of the triangle AOB is 6, find the values of C. Alright, most of the time, guys, this is a little hint by the way. If they ever say value with the bracket of S, about maybe 70 to 80% of the time it's going to be multiple values. So just keep that in mind. It's very rare that they say values and you only get like one value. Okay, so most of the time it's going to be like 2 values. Okay, alright, so let's do it. I don't know if that's the case here, because remember, I don't know the answer to these questions. Maybe, could be, but I don't know. Alright, let's sketch out a graph. It's y is equal to negative 3x plus c. Okay, let's just pretend, for example, let's just pretend c is here, because we don't know the value of c, but I'm just going to pretend it's there. Okay, and it has the gradient of negative 3. That's easy to draw. It's going to look something like this. Alright, so what's the x-intercept? The x-intercept is going to be c on 6. What was it? C on 6? No, x-intercept, I'm sorry, x-intercept was c on 3. C on 3 and 0. Right? So remember, the y-intercept was what? Y-intercept was coordinate b. Right? Y-intercept was, this was b. X-intercept was a, and origin is o. Okay? In pretty much, in this question, they're saying that this triangle, AOB, so this triangle A to O is here. O to B is there. And then there. That thing in purple is the triangle that we're looking for. Pretty much they're saying the area of this triangle is equal to, this area is equal to 6. Okay? And then we need to find the values of C for that, to make this area 6. Alright? So firstly, what is the area of a triangle, guys? Area of a triangle is half times base times height. Right? That's the area of a triangle. So area of this triangle is half multiplied by, what's the base of this triangle? Well, base is the distance from here to here. Right? What is that distance? Can you tell me? Well, the distance is c over 3, right? Because that's the x-coordinate, how far right to the origin you are. So the base is going to be c over 3, right? And then what's the height? Well, the height is, again, the height of the triangle is here. That's the height. Right? What's the height? Well, it's going to be c. It's the y-intercept. It's the vertical distance from the origin. So height is just c, right? So if you multiply all that together, you should get c squared, because c times c is c squared, over 6. That's it. Then, what we need to do? We have to say the area. So this is the area of the triangle in terms of c, right? So pretty much from my equation, we got this area is pretty much c squared over 6. Right? What is the question saying the area has to be? The question saying that our area, which is c squared over 6, has to be equal to 6, right? So it has to be that we got that 6. We got that 6 from the question. It has to be equal to 6. All right. So let's pretty much solve this and find the value of c. So you take 6 to the other side by multiplying. C squared is equal to 36. Then you have to say c is equal to plus or minus. Remember, guys, every time you square root, you have to do plus or minus 36. So c is equal to plus or minus 6. Okay, so your two options, c is equal to 6 or c is equal to negative 6. So your two answers, which is, remember what I said before, values, multiple values. Okay? Alright, so you got two answers for c. C is 6 and c is negative 2. Alright, that's it guys. Last question, last couple of questions. We have to do part 4, which says that the midpoint of AB, right? We already found the midpoint of AB in the previous question. What is the midpoint of AB? It was c on 6 and c over 2. Right, we find this in the previous question. Is such that the distance O to M, so the origin to the midpoint, is this, root 10 on root 9, where O is the origin, and then we have to find the value of C. Okay, it's really confusing. So let me break this down to you by drawing the same graph again, what I drew before. So again, I'm going to draw. Again, you see how I'm drawing a lot of these graphs? Okay, it's really helpful, guys, for a lot of these questions if you're able to visualize it with graphs. That's why I keep drawing them a lot. Alright, so if I draw this graph, it's saying that this is coordinate A, oh no, sorry, it's coordinate, what was it? Yeah, coordinate B, my bad. B, which was the y-intercept, was 0 and C. And the x-intercept, A, was C on 3 and 0. Okay, so remember, it's pretty much exactly what I drew here. Alright, so it's saying that the midpoint of these two lines, which is roughly in the middle, the midpoint, remember we found, was C on 6 and C on 2. Right, the midpoint of that line, such that the distance from O to M, so remember O is origin, they're saying that this distance from the origin to the midpoint, this distance over here, is equal to root 10 over 9. Okay, that's what the question is asking for. The distance from origin to midpoint is root 10 over 9. Right, so how do you do this? Okay, if you'll go back to the distance, the very first lesson in this chapter, it's kind of very similar to that. So you have two coordinates, 0, 0, and C on 6, C on 6 and C on 2, and they're saying that the distance between these coordinates is equal to root 10 on 9, right? It's very similar to what we did in the first lesson. So then we got to use the distance formula. I'll remind you of the distance formula is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to ignore this part for a second, and we're just going to use these values, x1, y1, x2, and y2 to get the distance between these two coordinates first. So let's do it. So distance is equal to square root of x2, which is c on 6 minus 0, plus x1 is y2, my bad, I got confused there, c on 2 minus 0 squared. So both of these are squared. Alright, so let's try simplifying this first. So this is going to be pretty much c on 6 minus 0 is just c on 6 squared, c on 2 minus 0 is just c on 2. So c on 2 squared. So pretty much distance, if you simplify all of that, if you expand this square in, is going to be c squared over 36 multiplied by c squared over 4. Remember the formula of the exponential formula, if you guys forgot, I'll write it here. If you have a on b to the power of c, that's the same as a to the power of c over b to the power of c. That's how we did the exponentials. Alright, so now we find the distance. Now what should this distance be? The distance between both these coordinates has to be the same as square root of 10 over 9. That's what the question is saying the distance has to be. So pretty much we can, again, we do it similar to how we did it before. We square both sides, like so. And so you're left with c squared on 36 times c squared on 4. Sorry, not times, it's add. I made a mistake. Remember the formula is add. So plus is equal to 10 over 9. Okay, remember if you square both sides, you can get rid of square roots. And from here, guys, we just need to start solving. Okay, so we can say c squared on 36 plus, so you got to make this on the denominator 36, so times top and bottom by 9 over 9. So 9c squared over, and then over 36 is equal to 10 over 9. So if you add both of these together, it will be 10c squared over 36 is equal to 10 on 9. Take 36 to the other side by multiplying. So you have 10c squared is equal to 10 on 9 multiplied by 36. And if you cross simplify, instead of multiplying these two, I can cross simplify. 9 goes into 9 once, and 9 goes into 36. How many times? Because 9 goes into 36 4 times. Okay, so what are you left with? 10c squared is equal to 10 times 4 is 40. Let's keep going. C squared is equal to, you need to divide both sides by 10. C squared is equal to 4. And then C is equal to plus or minus. Remember, every time you square root to the other side, you have to do a plus or minus. So square root of plus or minus 4. So C is equal to plus or minus 2. Okay, so that's it. What's the answer then? Well, c can be negative 2 or c is equal to 2. Okay, so that's pretty much the question. So what this is saying is that if c over here is negative 2 or 2, then this distance is going to be square root 10 over 9. That's it. Alright, I hope you guys understand. That's it for the lesson. I'll see you soon.